So on a whim, I saw a paper on people using carrots as a reducing agent for ketones, which I'm not entirely sure what they are, but it's basically acetone. And the ketones were reduced to secondary alcohols using carrots. So I did a little more research. I'm not chemically inclined. I have zero scientific background. But from what I understood, there's enzymes in the carrot that perform reduces, and I wanted to test if it would reduce some harmaline to THH, triheptaharmaline or something. And just as like a fluke, I did it, and I do think it worked. You can see there's a clear blue hue where originally it was green. But again, I have to repeat this since I didn't do any control or anything. So that's what I'll be doing in this video. If you have a better understanding of the process, try to explain it in layman terms to me. I would appreciate it, but this is what I'll be attempting. So for the original reduction, a pure zinc powder or magnesium strips, pure as possible, is used in a acidic aqueous solution with the alkaloid you're trying to reduce. I'll be using a far excess of magnesium. This could easily be used for maybe 2 or 3 times the amount I'm using. So this will guarantee that the reaction is complete and there's no unreacted harmaline. And here is the harmaline. So here is the pure harmaline, and this is the Cappy tea. The harmaline, this one, the light is pretty similar. The color of the black light is pretty similar to this one. However, this one's a bit darker. So now I'll just give this a quick wash. I'll remove the 2 ends, and I'll be shaving this to a smaller size so that it has more surface area. And I'll divide it between these. It'll be one more with a control for water, and I'll divide it evenly for the 3. And here's my anhydrous carrot shavings. And from here, I'll again split it up into 3, approximately equal amounts, and start the experiment. So here is the magnesium shavings. It should form some bubbles, which it has. It's fizzing and it's releasing hydrogen and reducing the harmaline. And then now I'll be putting the carrot shavings in the meantime. So I'll be leaving this for 2 days, so that it has more opportunity to perform. And yeah, here you see there's a color change already from the reaction. And let's test the blacklight. So this is already a brighter green, but it's still a green color, even though it's coming up blue on the camera. It's still the harmaline green. This one is also still the harmaline green. This is a much darker green color, but nothing really changed for these. And these two are still the same color as well. And there's no UV reaction, blacklight reaction to the carrot control. So it's been 2 days, and you can see the color. It turned to a bluish color, bluish hue. And the carrot and the magnesium strips are, I would say, identical. The complete tea with the harmines is a brighter shade. It's hard to see now because of this sunlight and my blacklight is weak. The complete tea with the carrot has become a brighter shade, the luminescence, but something that didn't happen to the others is it seems to be fermenting. You can see the bubbles, most likely it's CO2. And I assume, since the tea is not purified, the excess fructose and glucose and the other sugars in the cappy are fermenting with the carrot, and it's causing the fermentation to start. With the magnesium strips, I'll filter it out once, just to filter out the magnesium strips, and then I'll add approximately 30 grams of sodium chloride so that the harmalines precipitate out. This is known as the Mansaki technique. It's the name of the scientist, and it works out to prevent the magnesium from precipitating out. So here is the salt saturated solution of the magnesium strips. So this is the carrot experiment, and this is the magnesium strip experiment. The main difference is the coloration. I didn't use a large amount, so the yield will not be measured. So it's not the easiest to pick up on the camera. But the magnesium strip is slightly bluer. And this one is more of a green. So I don't think anything was converted, but it's very hard to tell.